All right, so hello everybody. My name is Henry, and I'm really happy that you have me here. And the topic I would like to tell you something more about today is the software for IoT Gateway and some other things surrounding this topic. So before we start, just a few words about me. So my name is Henry, as I mentioned before. I work as engineer at Red Hat, and I'm involved in many open source projects. Just to mention some of them is Apache Camel, Eclipse Kura, Eclipse Kura, and Fabricate. Okay, and in this talk, I will be talking about about software for IoT gateways. And maybe, just to be sure before we proceed, is like, how many of you know what is IoT, Internet of Things? Okay, anybody don't know what IoT is? Don't be shy, I can explain. Okay, all right, so that's cool, so we can continue. All right, and as far as the structure of the talk is concerned, I would like to talk in the beginning a little bit about the architecture of the IoT solution, and talking about the architecture of the IoT solutions. I'm thinking about the architecture as we see it in Red Hat, because I'm working for Red Hat, so in general my vision of the IoT stuff is in sync with things that we are doing here at Red Hat. After talking about the architecture of the IoT Gateway, I would like to, and IoT solutions in general, I would like to talk a little bit about the messaging and why it is important in the context of the IoT. Then I would like to focus on the gateway itself, and then I would like to proceed to and talk a little bit more about the backend for IoT, which is also an important part of this IoT puzzle. All right, so architecture. The first and the most important thing when we are talking about Internet of Things is that from our perspective, IoT is really a kind of specific use case of the messaging. And many people are surprised when they hear that. Or for example, when I told them that the team I'm working in at Red Hat is a part of the bigger messaging organization within the Red Hat, they are kind of surprised, like why IoT is the part of messaging, because IoT is all about the devices and messaging is about messages, right? So the thing is that IoT is really a kind of specific use case for the messaging, because you can think of the IoT as the scenario for the messaging when you have many devices, like it can be hundreds of devices, thousands of devices, or it can be millions of devices, and those devices are connected to a kind of backend system, and they are sending many messages, many small messages usually, like for example telemetry messages containing a kind of temperature readings or stuff like that. So if you think about this, IoT is a kind of really demanding use case for the messaging. And in order to support this kind of demanding use case for messaging, you need to provide a kind of architecture that's able to support this kind of workload. So the general architecture, all right. All right, so the general architecture of the IoT solutions that we propose here at Red Hat is presented on this diagram. And it's like, let's start with the, is my fault? Okay, so maybe. No, I'm not doing anything, but maybe I will just like, okay, do something with that, maybe that will help. Okay, anyway, all right, so on the left side of the diagram, there are, maybe I need to do this another time, okay. All right, anyway, I will just continue to do the talking. All right, so on the left side of the diagram, we have the devices. So the device can be, it can be a typical IoT device, like, like connected car or something, as fancy as connected car. But it can also be something like mobile phone or different machine, different IT system, because it's like the IoT device is actually a really broad term, right? So this is not necessarily something you read about at TechCrunch or something like this, but it can be also, just while the default protocol for the IoT messaging that we propose is IMQP, and I will talk a little bit more about it later, why IMQP is the preferred one. You may be asking, what if I would like to use some of the popular IoT dedicated protocols like COPE, LW, M2M, MQTT, or other stuff like this? If you would like to use this kind of protocols, you can use something that we call IoT connector, and this is a kind of small process that is responsible for bridging the protocol like MQTT into the IMQP. And then you have backend services that can read from the IMQP cloud and that can process the messages that are sent from the devices. Okay, and now a little bit more about the messaging that is responsible for being the backbone of this architecture. Okay, so the messaging part is really that thing in this circle, and let me again use that. Yeah. Okay, so I'm talking about this circle. And this is the part that we call messaging. This is the part that's responsible for receiving messages, for probably store and forwarding them, but this is not the required part, and for dispatching them to the other services that are interested in consuming those. And this part need to be scalable, and it's really important thing, because when you think about the IoT systems, the volume of the messages that are processed by this kind of system is like really big, and it's like really enormous kind of volumes. So probably putting a single ActiveMQ broker or RabbitQ broker or something like that in the front of like 10 million devices probably would not be enough, and probably won't scale enough. So the thing is that when you are putting something between your devices and between your backend services, it should be really scalable. And one of the propositions of such scalable things that you can put between devices and between backend services is, for example, a solution that is based on Qpid dispatch router, which is a kind of, it is a really simplified definition of what Qpid dispatch router is. But it's like a really short definition of Qpid dispatch router is like, it's a kind of, you can think about it as a kind of server that acts like a proxy between IMQP client, one IMQP client and the other IMQP client. So it can be used, for example, to act as a proxy between client and IMQP client and IMQP broker, between two IMQP clients. And the thing is that it provides you things like, for example, multiplexing of the connection, which makes it much easier, for example, to scale the large amount of the devices connecting to your messaging infrastructure. I mentioned the protocol adapters just a moment before. So the thing is that you may be asking, for example, why should I, because, for example, I have read that MQTT is like messaging protocol for Internet of Things. So the question is, why shouldn't I just create, the MQTT broker or something like that and use that instead of IMQP messaging? So the thing is that in general, scaling IMQP, I won't say that it's easy, but in general, scaling out IMQP protocol is much easier than scaling, for example, MQTT. So this is the primary reason why you should think about having IMQP as a backbone messaging for your solution, and then having only a protocol adapter between the device and between your messaging in order to provide support for different protocols that are dedicated for IoT, like MQTT, like LW, M2M, and the others. Okay, and this is like this question that that many people ask me when I'm talking about the things that we are doing at Red Hat. So I decided that I should have this slide here. So it's basically like when I'm talking about Internet of Things and messaging and stuff like that, everybody asks something like, "Okay, do you have Kafka in that?" It's like, will you be using Kafka and stuff like this? So I'm not in the position to give you the definite answer, like we will be using that technology or not, but definitely Kafka is something that that we consider to be a candidate for example, for stuff like telemetry data. Because if you think about Kafka, is like, you know, and about IoT, probably your first thought would be like, you know, that could be a cool technology for storing telemetry data, because Kafka is like, you know, well designed for storing really large volume of the messages, having a kind of persistent record of that, and then having multiple consumers that are able to read the history of the telemetry data. So for example, you can read that, put that into a kind of, you know, as a source for example, Spark streaming or Spark Analytics or something like that. So it's like, it's pretty likely that over the time we will introduce a kind of Kafka probably for the IoT telemetry stuff. And another important project that is related to things that we are doing in IoT is a project called Eclipse Kura. And we are working together with Bosch on that project. It's like the project is like this open project that like actually, you know, any company can participate in that. But so far Red Hat and Bosch are the primary contributors to this. And it's like the goal of Honor is to, the goal of Honor is to provide a kind of subset of the messaging based on the IMQP that is dedicated only for telemetry and only for very limited scope of device management. But its goal is to provide only those narrow functionalities, but at large scale that can be used for like big companies, for example, like Bosch. Okay, so that's like, you know, the bigger context of the IoT architecture and IoT infrastructure that we are working on. And let's focus now a little bit more on the gateway thing. So what is that IoT gateway? So it's like really short definition of why gateway is. It's a gateway is a kind of proxy between devices that are deployed in the field and between the data center. And it's like, you know, the first question is why I need this kind of proxy, you know, because when I read articles on TechCrunch and many other portals, it's like, you know, that everybody is talking about the thing that every device will have its own IP address, it will be connecting to the internet directly and stuff like that. But it's like, you know, this kind of vision, like every device having its own unique IP address, it's a kind of futuristic vision, really, if you think about this, because the reality is that the majority of the devices that you put on the field is not capable of holding the whole IP stack, right? Because if you, for example, like to put a temperature sensor somewhere and read that data from the sensor and, you know, send it to the internet, then if you would like to make that sensor capable of connecting to the internet directly, it means that, first of all, it will be much more expensive than it is currently, right? Because, you know, this is a different class of hardware that is able to handle something like, for example, Wi-Fi chip. And also it means that that device would consume pretty much of the battery, because, you know, having something like Wi-Fi card on board means that the battery consumption will be pretty high, and this is a problem really for the IoT scenarios. So the reality is that not every device, especially at this point, have its own IP address. Actually, the majority of the devices that you deployed into your IoT solution in the field won't have its own IP address and will be able to connect only to a kind of small computer that is also deployed near to them, and that device is the gateway. So you can imagine, think of this like, for example, let's say that you take something like Raspberry Pi, and that will be your gateway. Like, that will be the small computer that you locate somewhere in the field near to your sensors. Then you take something, for example, like temperature sensor that is able to send messages to that Raspberry Pi using, let's say, Bluetooth Low Energy, right? But only Bluetooth Low Energy, and not, you know, so it means that it is able to send that telemetry data from that temperature sensor only within the range of something like, you know, 20, 30 meters, something like that, and it definitely won't be able to send that message directly to the internet without using the gateway, right? So this is the primary reason why you need the gateway. And the project that we decided to adopt for the purpose of providing IoT gateway solution at Red Hat is called Eclipse Kura. And Eclipse Kura is really nice project from the Eclipse Foundation that is dedicated for creating software for IoT gateways. It is based on the OSGI, and you can think really of it as a small OSGI server with some OSGI services deployed into it, and a little bit more about the services soon. All right, so those services provide you a kind of higher level of the abstraction of the common task that you would like to perform in the field. So, for example, like the common task that you need to perform when you deploy things like even Raspberry Pi IoT Gateway is like, for example, you would like to provide a kind of configuration of the firewall, or for example, you would like to be able to react on some events related to network. So, for example, you would like to detect if Wi-Fi network is within the range of your gateway or not, and stuff like that. Or, for example, you would like to be able to read, for example, to read messages from Bluetooth Low Energy module. So, this, for example, requires to read that telemetry. That temperature reading from that sensor that I mentioned a moment before. Like, so if you get that the sensor, and this sensor uses Bluetooth Low Energy to send the information about temperature, you need something on the gateway that allows you to read that information from Bluetooth module. So this is the kind of functionalities that are provided by Kura out of the box. And it's like, who's behind Kura? So the company that created Kura is called Eurotech. It's like Eurotech is a really, really cool company. It's like I used to say that Eurotech was doing IoT before it was cool. So Eurotech is primarily, I think, the embedded hardware company, and like they moved into the IoT world over the time. And they created this project for their needs, and at a certain point of time they decided to open source that, and that's how Kura has been created. And the other important news that is, oh, okay. And the other important information related to Eurotech is that some time ago Red Hat established a partnership with Eurotech, and like so starting from, I'm not sure when exactly it happened, something like probably half an ago or something like that, and we are partners from that point, and we are working together to deliver cool stuff like joint IoT gateway solutions. So if you take a look at this picture, so this is like so this is a kind of example of enterprise level gateway, because previously I mentioned that you can put Raspberry Pi into the field and you can use that as a gateway, and it's technically it's true, you can do that, of course, but it's like in practice, if you are going to a really, really big enterprise company, you probably won't offer them like we can deploy Raspberry Pi into production, and it would be cool, right? So you need something that is more reliable, and this kind of reliable software that has been tested in many environments is this. So you can think of this board really as a kind of Raspberry Pi or steroids. So it's like enterprise level Raspberry Pi. Yeah. Okay, and for example, this thing here, so this is a kind of nice hardware provided by Eurotech, and inside it will have Kura and it will have Camel. So the productized version of Kura is called ESF, and I think it stands for Everywhere Software Framework. And the productized version of Camel that you can find there is really JBoss Fuse, so you probably have heard about it. Okay, and now talking a little bit about this Camel part that is deployed there. So first of all, who knows what Camel is? Okay, so almost everybody, so that will be really short introduction for the few people that don't know. So Apache Camel is a message routing framework. And what is message routing? So message routing is really like an implementation of the Enterprise Integration Patterns book, which is a really, really awesome book, by the way. If you are doing the messaging and integration based on messaging, is like this kind of Bible, and I highly, highly recommend that you read that book. It's really awesome. And that book describes a kind of patterns, and there are some open source project that provides implementation of those patterns. We have Apache Camel, the other project is pre-integration, the other one is Moo, and all those projects basically tells you how you can orchestrate the flow of your messages. And of course, Apache Camel is the best of those projects. And I'm not telling this because I'm the committer. Okay. And if you are looking at the Apache Camel, so just to give you a kind of insight how a sample application of Apache Camel could look like. So this is a kind of snippet written in Groovy. Groovy is a kind of Java on steroids, really. And this simple, for example, this application demonstrates how to read the message from a JMS, transform it to JSON message, and then concurrently save it to FTP server and to MongoDB. And of course, you need to provide the kind of configuration for FTP and JMS credentials, stuff like that. But that's really all you need in order to perform this task. So if you think about this, like, you don't need to create much code in Camel to create this kind of typical message flow. So, it's really cool. It allows you to save pretty much of the boilerplate. And the question is, like, there's also like another question, like, that many people ask me, like, why, guys, you decided to put Camel into that IoT gateways? Like, what is the benefit of that? Because Kura, people were using Kura without Camel for many years, and it was like, they were happy with that. So, what is the value added by Camel here? So, first of all, Camel provides over 200 of OSGI-ready connectors, and that OSGI-ready thing is a pretty important statement, because as I mentioned before, Kura is based on OSGI, and it means that in order to deploy something into Kura server, it should be OSGI compatible. And the thing is that if you will just take a random library and try to put it into OSGI, you may run into some problems. And if you are deploying one of the connectors from Camel, which has been heavily tested by Camel team against OSGI, you can be almost sure that it will run without any issues. So this is like, time saver for you. And of course, you have all these kind of connectors that are really useful in the context of the IoT. So you can think, for example, for JMS messaging, for IMQP, for REST, for COAP, for MQTT, and stuff like that. So if you would like to connect to some kind of protocol that is more or less IoT related, it's very, very likely that Camel will provide this component for you, so you don't have to create it from scratch. And the other kind of the benefits that comes with Camel are related to the patterns described in this enterprise integration patterns book. And let me just describe some that are, in my opinion, the most important. So for example, something called throttler. So this is the enterprise integration pattern that allows you to tell how many messages in a certain time interval should fit into a given channel. So in practice, it means that, for example, if you have a temperature sensor and that sensor sends some data related to the temperature that, for example, it reads some temperature change, it sends it to the gateway, right, over Bluetooth Low Energy. So, it's cool, you created this kind of route, you read this kind of stuff. But the thing is that if that sensor will, for various reasons, will start to generate many, many messages, and don't have any logic that prevents data overflow, it means that you will continue to send many, many data into the data center. So now imagine that your gateway is running, for example, on the paid GSM plan, and it's very, very likely that your gateway will be running on this kind of paid GSM plan. So it means that, for example, at the end of the month, you will take a look at your GSM provider bill, and it's like it's very likely that your project will be terminated at that point. So the throttler, it's a nice thing that allows you to tell something like, for example, okay, I would like to read the temperature from the sensor, but I'm interested only in, for example, 1 reading per second or something like that. So if the sensor will generate more than a single message per second, just ignore that message. Don't try to send it to the data center. So it's like really, really useful for the IoT scenarios. The other thing is, for example, content-based router. So it's pretty simple thing, but really, really powerful. It allows you to provide you a kind of intelligence to the gateway. So basically, you can create a kind of rules in different kind of expression language. It could be Java. It could be a thing called simple expression language, which is a kind of expression language provided by Camel. You can use Spring expression language, Groovy expression language, many, many other supported formats. And you can use that in order to decide at runtime where the message should be dispatched. So it's like, again, the common example is something like when you read that temperature from that sensor, and for example, the temperature is higher than some threshold value, then you would like to send a kind of priority message to your backend services, because it means that, for example, something is burning in the field, right? So, for example, device is burning because temperature is like too high, something like this. So this message should be sent with the higher priority in order to send a kind of notification to some operation guys in the field or something like that. So it's pretty common task, and it's really useful to have support for that in Camel. And the other thing, for example, is client-side load balancing, which is available in Camel, which allows you to specify a list of endpoints that should be used by Camel when it tries to connect to something. And it means that you can specify the list of the services that can be used by Camel. So, for example, if you would like to send this temperature value from your gateway to your backend services, then you can provide the list of the backend services that you would like to connect. And it means that if for some reasons you can't, for example, establish a connection with given protocol to a certain backend service, you can fall back to kind of to some other connectivity scenarios. So, for example, you can use that to, for example, try to connect to your MQTT server, but if that server is not reachable at this moment, and in the IoT world, it's very, very likely that the service that would like to connect from the device won't be available. So this load balancer thing allows you, for example, to store that message in the memory of the, for example, on the SD card, and then perform a kind of processing later. And other thing, for example, is control bus. A control bus is something that allows you to dynamically specify which part of the routes should be enabled and which should be disabled, and I will talk about it a moment later. Okay, so as far as Camel and Kura architecture is concerned, so basically when this is something that should be familiar to Fuse and Service Mix and Carafe users. So basically it means that when you deploy a module into the Kura, it creates a separated Camel context. So this is the same architecture model that is used by Fuse. So if you are a Fuse user and you would like to use Camel, it's like you will feel like at home. And if you are interested, like what the code of such a module for Kura and Camel could look like, all you need to do really is extend a base Camel class, base class that is called Camel root, and then define the root. You know, it's the API that you know from Camel already, so it's nothing fancy here. And all the additional logic related to Kura is performed by the base class that you extend, and you just define your root, and that's really all. And for example, it's like this snippet here is the example that I used, for example, to read from this special webcam component that has been created for Kura, and that webcam component can be used, for example, to read data from camera that is attached to Raspberry Pi. And for example, with this code snippet, you can read data from that camera at Raspberry Pi and send it to your data center with HTTP and with REST protocol. Okay, so some other example is like, for example, you can use a route like that in order to start small HTTP server based on NETI on your gateway device, and that small server can be then used to display you the name of the Wi-Fi networks that are available for access for the gateway device. Okay, and this example is like a little bit more fancy. So again, so now, for example, imagine that you have something like connected car, and let's say that, for example, you would like to collect some data when you're driving, but you would like to sync up this data only when you return home, because when you return home, then you are connected to Wi-Fi network, and then you can use that Wi-Fi network in order to send this kind of big data to avoid creating big GSM billings. So for example, this kind of route can be used to detect if you are within the range of the Wi-Fi network that is defined as your home network, and if you are within its range, then this sync process of the data cached on the gateway device will be started. Another interesting thing that comes with Camel and Kura is route management on the runtime. So the previous example I demonstrated to you was based on something called Java DSL for Camel. So it means that you define routes as Java code really, but Camel allows you also to define this kind of routes using XML files. And it means that you can define this kind of XML routes on the runtime. You can open something called Kura Web UI, so you can see how it looks here. And you can open it, and then you can provide this kind of module, this kind of route definition on runtime. So you can update your Camel routes without restarting the gateway, which is a pretty cool feature, especially in production when you have this deployed in the field. And starting from the version of Kura, starting from version 2, which has been released something like 2 weeks ago, I guess. Camel is a core part of the Kura. Now Camel is distributed as a standard library with Kura, so we don't have to install it as external module anymore. It just will be there out of the box. And what also we plan as the next steps for Kura and Camel integration. So currently I'm working on the rules and BRMS integration with Camel and Kura. So it means that if you would like to have more complex rules defined on the gateway, it will be possible soon with rules and BRMS. We are also working on additional Camel components dedicated for IoT only. So for example, we are working on dedicated Bluetooth Low Energy modules, Modbus, and stuff like that. And also we are working with better integration with managing external processes. So for example, you will be able to start external processes from Kura. In particular, you will be able to start things like Docker processes from Kura, and for example, making sure that that process is running, and for example, if it dies for some reason, Kura could be responsible for restarting that. And this is also something that is pretty important when it comes to IoT, because like in IoT there are many existing libraries that are not written in Java, and it's very likely that you would like to run them, for example, as a separated process or Dockerized as Docker containers. So it would be just nice to have a kind of single point of managing all of this kind of stuff running on your gateway, and that single point of management would be in Kura. Okay, and just for the end of the talk, a little bit about the backend stuff, because this is a kind of another question that always occurs when I'm talking about the stuff I'm working on. Is like, okay, so we got this messaging thing, so we got this gateway stuff, you read the data from the sensor, but what can I do with the data? Where can I send it, right? So it's like, I like to say that what we currently have as Red Hat in JBoss middleware and stuff like that in the context IoT. So we have a kind of, many components, right? So, you can, for example, have Fuse and stuff like that. You can put that on the backend. You can deploy stuff like, like Wildfire or something like that. You can deploy that as a backend and create this kind of IoT solution based on that. But that would mean that, we can provide you many building blocks, but you don't have all this kind of, glue that is needed to wire this all together. We don't have also a kind of specific services, for example, dedicated for device management. So it's like still, if you would like to create, if you would like to have a device management, you have to write it by yourself and create it by yourself. So ideally, what we would like to have is like to have a kind of end-to-end IoT platform. So so you can really deploy one thing that will provide you everything you need. And this is the primary reason why we are interested in working together with Eurotech on open sourcing another of their projects. Okay, so it's like, and our ultimate goal in the context IoT would be to have all of those projects combined, like Kura, Hono, Everywhere Cloud, combined together and delivered, as a single end-to-end solution for the IoT. So it's like, so if you are interested in this kind of stuff, I highly recommend, to follow the news from Red Hat and Eurotech and from projects like Eclipse Kura and Eclipse Hono. Okay, so that will be all from me.